Hello everyone, my name is DikshaJamdade. My roll number is 4160. Today I am here for presenting my video presentation of ISE1 of the course Blockchain Technologies, and the topic assigned to me is Advanced Cryptographic Mechanism in a Blockchain. So there are 9 to 10 mechanisms in blockchain. So we will see it line by line. Okay. So the first one is cryptographic hash functions. A cryptographic hash function. What is the cryptographic hash function? Hash function is a function that we use to convert the input data into a fixed size of output data. So a cryptographic hash function converts input data into a fixed size output called a hash value. Okay. So for example, if we want to convert hello into a hash value, then it will look like hello hash function will generate a unique hash value. Unique hash value means that is it is an encoded value or it is an encrypted data. So most important properties of the hash functions are when for the same input we will always return a same output. If there is any small change in input, then there will be a lot of change in a output, that is the hash value. Then we cannot convert hash value into original data. We can convert data into a hash value, but we can't convert the hash value into a data. So likewise, even a small change creates a completely different hash. Okay, even a small change in a value. So someone suppose uh, if we want the hash value of hello and we enter the only single edge, then we will get completely different value of hash. Okay, then in a blockchain, hash functions are used to connect blocks and detect any data tampered means hash function, with the help of hash functions we connect the blocks in a blockchains. So if there is any small change in a hash value, then there will be a tampering of data. So if someone changes the data, the hash changes and the tampering is detected. Okay, so it was the cryptographic hash function. Then SHA-256A. SHA-256, that is SHA stands for Secure Hash Algorithm 256. It is mainly works on 256 bit of data. So it generates a 256-bit hash value and is widely used in blockchain, especially in a Bitcoin. Bitcoin is a cryptocurrency, or Bitcoin is a one of the technique of the blockchain. So it is used to generate block hash. uh, Block hash means the blocks we are using in a blockchain are created with the help of hash value, that is the so for that hash value we have to use SHA-256 algorithm. Secure transaction, that is SHA provides a security, integrity and durability of the data, and it helps to connect the blocks. So SHA-256 is very secure, makes it most impossible for hackers to break the blockchain. So even if one small change is made, the hash changes completely, so there is a damage to a full blockchain. So third one is public key cryptography. Public key cryptography, it is also called as asymmetric key cryptography. It uses the two keys, that is public key and private key, for the encryption and decryption. So the private key is a secret key and used to sign the transaction, and the public key is the shared and used to verify the transaction. So this system ensures that only the owner can perform the transaction. Okay, so what it ensures? It ensures security, safety, and the durability of the transaction. So, as a private key is a private key for the user, it is only known to the owner, and the public key, it is the public key or the shared by the users to verify the transactions. Okay, so it helps to maintain the security and privacy of the data in public key cryptography. So, the fourth one is digital signatures. Digital signature is used to verify the identity of the sender. So it is the key, or it is the proof that this author is authorized or the owner is authorized. It works like a handwritten signature, but it is in digital form. So before verifying or before before validating any document, we check the original signature. Likewise, digital signature means it is the digital copy or the digital proof of the document, that is the owner is authorized or the document owner is identified. When the user sends a transactions, the user sends it using their private key. Okay, when the user sends documents, then it is a uh, digital signature. It is a kind of the code word that is only known to the sender and receiver. The network verifies it using their public key. Okay, this ensure transaction is authenticate, then genuine, and no fake transaction are allowed in digital signatures. The main use of digital signature, it prevents fraud in blockchain. So hash pointers contains two things: the address of the data and the hash of the data. It is used to connect it is it is used to connect blocks securely. Each block contains the hash of the previous block. Each Okay. So as in a hash pointer or the blockchain, the block in a blockchain contains the hash value of the previous block. So if someone changes the data in the block, the hash changes. This makes tampering easy to detect. This is how blockchain becomes tamper proof. So Markle tree. Markle tree is basically a tree-like structure transaction verify used to store and verify transactions data efficiently. That is, the transactions are converted into hashes. These hashes are combined to form a single hash called a Markle root. Okay, so in a Markle tree, there is a Markle root who is the combination of all the single hashes. Markle tree helps to verify data quickly, detect tampering, improve efficiency. It is used in Bitcoin and other blockchains also. Co- Consensus mechanism. Consensus mechanism is the process used in blockchain to make sure all the participants agree on the same information. That is, the consensus means it is an agreement that can be agreed by all the users on the same information. So since blockchain is decentralized and there is no central authority, consensus helps us all computers, all nodes agree on which transactions are valid. It prevents fraud and ensures that no one can add a fake transaction. So, uh, so increase the surety or integrity of the data. Consequence mechanism is very much important. When a new transaction happens, the network verifies it using a consequence mechanism before adding it to the blockchain. So this mechanism helps to maintain security, trust, and reliability in the blockchain. Zero knowledge proof. Zero knowledge proof is an advanced cryptographic technique used in a blockchain to protect user privacy. It allows a person to prove that they know some information without revealing the actual information. You can prove that you know your password without telling your password. Okay, it is a kind of technique that in which we can prove that we know the password without telling the actual password. This helps to protect sensitive data and improves privacy. It increases security, privacy, and trust in the system. Advantages of the cryptography in a blockchain. Cryptography provides many benefits like high security. Cryptography provides many benefits like high security, prevents data tampering, protects user identity, ensures secure transactions, build trust in a blockchain. Without cryptography, blockchain would not be secure. Blockchain without cryptography is used for information network security. It is a kind of information network security which securely stored our information with using with emphasizing integrity and data surety. So thank you.